Okay, good evening. Okay, first thing first, this announcement, okay? Now, because of the order of the class, okay, the Tuesday class is supposed to be after the lecture, not before the lecture. So in order to synchronize your tutorial and your lecture, you will not have any tutorial next week, okay? So no tutorial, no Tuesday tutorial for Tuesday tutorial class, clear? So your tutorial will continue next week, 14th of May. So it means you will be 1 week late. So your tutorial will end in week 15 instead of week 14. Clear? Okay? So the Wednesday tutorial is supposed to be the first tutorial after the lecture. The second tutorial is the Thursday tutorial, and Tuesday tutorial is the third tutorial. That's the order, okay? And you need to know this order in case you want to go to other tutorial class, okay? And for the recording will be done during the first tutorial, meaning during Wednesday class. So unfortunately, tomorrow is public holiday, so there is no class tomorrow. Okay, there's no class tomorrow. There's no tutorial tomorrow. Now, normally, if there is no class, we will not replace because it's recorded. But in your case, we will replace this because there's another public holiday on Wednesday. I think at the end of the month. Okay, so there's 2 Wednesday classes missing. That can affect you quite badly, okay? So for Wednesday class, there will be a replacement on Tuesday. Now, because the class is whole day, okay, for the tutorial, 6 tutorials, so it's not possible to arrange on any day, actually, okay? Because you have other classes as well. So there will be replacement next Tuesday for Wednesday class. Now, the attendance is not compulsory, okay, because you may have other classes that you need to attend. So the attendance is not compulsory. If you can attend, then you may attend, okay? Otherwise, you can follow or you can see the recording, okay? So the recording will be done during the day, and then you can see the recording in the afternoon. Clear? Okay? So the replacement for Wednesday class tomorrow will be next Tuesday. I will announce the class or the venue later. Okay? Clear? But it's not compulsory. Okay, because of the many schedule conflict, so you're not really required to come. But if you want to come, you can come. Clear? Okay. So Tuesday tutorial, no Tuesday next week. Wednesday tutorial, which is cancelled because of tomorrow public holiday. So your replacement will be next Tuesday. Any question? Clear? Okay, later I will post the actual time and the classroom. Okay, next item. Now for the attendance for Tuesday class, it will automatically be given, okay? Once the class is not during your actual time, your attendance will be taken automatically, okay? So you don't have to worry. For Wednesday class, no attendance will be taken, okay? For Wednesday class, this replaced on Tuesday, no attendance will be taken, okay? Up to you, okay? If you want to come, you can come. But it's a very important class. So if you cannot come, please, okay, please see the recording. Okay, see the recording. Okay, next one. This group. I posted this, I think, like 3 weeks. Okay. There's still more than 100 of you that have not given me your name. Okay, you're supposed to WhatsApp me your number, and then I will include you into the group. Now, once you message me, okay, the details, please don't expect me to include you immediately. Okay, once you give me your number, I have to check your name against my registered list. Then only I can add you into the group. Okay. Sometimes you change your group, and once you change your group, it is reflected in your timetable. But it takes few days for it to be reflected into the lecturer system. Okay, so it takes time. Clear? So be a little bit patient once you have given me your number. Okay, so don't expect immediately added into the group. I waited for you for 3 weeks to give me your name. Okay, so you can basically wait 3 weeks for your name to be included. So those who have yet to give me your name, please do so as soon as possible. Clear? Now, some of you have messaged me, okay? But you did not include anything, okay? You just message me and then just say, "Sir, please include me into your group." What is that? No head, no tail, no name. Who do you think you are? Taylor Swift? Van Diesel? PMX? Mamat? At the very least, put your name and your tutorial group. That's it. Clear? Okay? At the very least, your name and your tutorial group. That's all. If you don't want to put any other details. So if you send me your name today, so you can expect the name to be included probably end of the week. Okay. Now for Thursday tutorial, it will go on as usual. Okay. So Thursday tutorial, it will go on as usual with your tutor. Okay. Any question? Any question? Clear?
Sir, does Thursday's tutorial is online or offline? Because I'm Thursday students, but just now I received online courses invited on the Outlook.
Okay. Now, if you get that Outlook online invitation, it means your name is included inside the Teams. Okay. All of you actually should have your name included in your Teams. Okay, in Teams, but we may not use that. Okay, we only use Teams if there is any online classes. At this moment, there's no online classes. Okay, not yet, or there may never be online classes. Okay, but it's possible. For example, if something happened, so the lecturer or the tutor need to set online class. So only those who are inside that team, that Outlook, okay, can join, okay, the class. Okay, so that's why you need to be inside that Teams group. Or there's an extra class, or if there's some consultation, they need to be online. So you need to be inside that Teams. Okay, now that supposed to be automatically added for you. Okay, so all of you have Teams, so as Outlook, so that will be automatically added. Okay, so you don't have to do anything. Clear? And because we are not really using that, so at this point, you don't have to worry about that. Okay? Any question? 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 Okay, and then once you have added, you're supposed to be added to two groups, okay, two WhatsApp group. One is lecture group, the other one is your tutorial group. Clear? If you are not added to any of the group, your name is only in one group, either tutorial or lecture, then you need to inform me, okay? It may be purposely done because I'm waiting for the name to be included inside the list, or maybe I miss out. So you must message me, okay? You must tell me that your name is only in one group instead of two groups, okay? Okay, so today we will go through lecture week 1. Now you can ignore all this, okay, but this one is quite relevant, okay? This one is quite relevant. Now basically this is your journey, okay? Your journey in this semester. So you will learn a list, and then a stack, queue, and then a sorting, trees, and so on, okay? But it's not really in the order that you will learn. Okay, so all this stuff, okay, basically is what we will learn. Different data structure, and you also need to learn how to analyze the algorithm. This one has been changed, so just follow the one that we have. Okay. Okay, so what is a data structure? Now here it says data structure is basically a method to store information. Very simple. Okay. So in certain cases, you need to use a list to store information. Okay, so list is just a chain of storage. In certain cases, you may need to use this type of storage, like a tree. In certain cases, you might need to use this type of storage. A graph. Okay. So there are many methods for us to store information. So all this is known as a data structure. And what's the algorithm? Method to solve a problem. Okay. So in reality, if I want to solve a problem, there's a possibility that I need to store information. I need to retrieve the information. Okay. For example, if I want to do a sorting, I need to put the number inside a list. So in certain cases, in order for me to execute an algorithm, I have to use data structure. Okay. So algorithm, in most cases, needs some sort of data structure, especially if you are dealing with more complex algorithm. Clear? So that's how they are related. Okay? That's why you need data structure in algorithm. Not necessarily all, but in most cases. But how do we create data structure? I need to have some sort of algorithm. Okay? So before I can create this list, I need to have a step to create the list. So meaning I need to have some sort of algorithm. So to create data structure, I need algorithm as well. So you can see they are not independent. Okay. Algorithm need data structure needs algorithm. Okay. It's a symbiosis relationship. Clear? So that's how they are related. So in order for me to write an algorithm well, I have to know a suitable data structure. I need to know what are the most appropriate data structure given this problem. So I have a problem, I need to solve, I need to create algorithm, I need to know which data structure is most suitable for this particular scenario. Clear? So that's the reason why you need to know data structure, why you need to learn different or various type of data structure, so that you can apply the correct data structure for the correct problem. So meaning you will write an efficient program. Why must a program be efficient when new computers are faster every year? Why I need to create a more efficient program when my processor is becoming faster and faster and faster? What's the reason? Are you reading from here? More complex tasks, correct? Okay. Once we have more capabilities, we are going to execute more sophisticated, more complex items. Okay. Your ChatGPT, for example. Okay. Your ChatGPT require huge data structure. It's a neural network. It's a huge data structure. But we can create this data structure a long time ago. It's very expensive, but it's doable. But we don't have a fast processor. Okay? We don't have fast processor to process huge storage, huge data structure. So we cannot create this sort of program. Okay? But now we have. We have a very fast processor in order to handle huge data structure. So now we can have a new stuff. We have AI, we have ChatGPT. So the more the processor becomes, then you will create even bigger structure to handle more complex stuff. Something that previously, not that we are not needed, but we are not capable to do. So in 5 years, 10 years, we have more than ChatGPT. Okay? So because we are able to create faster processor, which enable us to handle even more complex data structure, bigger data structure. So it will continue on and on and on. Okay? Until you have children and your children have great-grandchildren, it will never stop. Okay? So I will go through the important stuff. Okay, principles of programming which relate to why we learn this entire thing on the first place. Okay. Now each data structure and algorithm has its cost and benefit. So how do I make it efficient? So you need to understand the principle of algorithm analysis. Okay, if I want to create an efficient algorithm, I need to know one of the things that I need to know is algorithm analysis. Okay, so one of the things that you will learn in this class is algorithm analysis. So toward the middle of the semester, we will shift from this pointers programming to analysis of algorithm. Okay, which is actually even though it's mathematical, it's simpler than what you learned before that. But we need to know, because that's how you compare two different algorithms. Because you can imagine, if I have a problem, so I ask Muhammad to solve, then I ask Mina to solve. So Muhammad gave me one program, one solution, and then Mina gave me another solution. So now I have two solutions. One from Muhammad, another one from Mina. So which one is more efficient? Which program is better? I need to be able to compare. So how do I compare? So let's say I run Muhammad using 100 data, and then I run Mina using 100 data, same data. Muhammad complete in 1 second. Mina complete in 10 seconds. Does it mean that Muhammad is better? Not necessarily. Okay. What if I give 1 million data? Then Muhammad finish in 1 minute. And then I give 1 million data. Mina finish in 50 seconds. Now Mina is better. So depending upon the data, how many data that you have, then the answer can be different. So this is where analysis of algorithm comes. Okay, how do we determine which algorithm is better? So we need to know. Okay, so you need to be able to analyze. So you need to know a little bit of mathematics. Okay, not high-end mathematics, just a little bit of mathematics. Primary school, kindergarten mathematics. Okay, so it's not a problem. Okay, next, the notion of trade-off. Now, whenever we want to create efficient algorithm, most likely you have this trade-off. Okay, time and storage, space and time. So in certain cases, if I want to make my program faster, then I need to increase the space. Now, in the old days, this is a dilemma that sometimes is difficult to solve. Because in the old days, storage is very expensive. Time is not so much. Nowadays, it's not the case. Nowadays, time is more expensive. Your storage is very cheap. Okay? So for that reason, in our analysis of algorithm, nowadays, we concentrate on time only, not the storage anymore. Because the storage has becoming less and less importance. Time has becoming more and more expensive. Okay? So our analysis of algorithm will concentrate on time and time only, not on space. Okay? Which make the analysis even easier for you. Now, another thing is you need to avoid reinventing the wheel, meaning you need to avoid doing the same thing over and over again. Not doing the same thing, but creating the same thing over and over again. Now, to avoid that, I need to know what are all the common data structure so that I can use. Okay, I can use. Or once I've created, I don't need to recreate. Okay, I can reuse. Okay, so that needs the knowledge of different data structure. And finally, so once I know everything, okay, all those three principles, then the most important thing actually is principle number 4. So given the problem, okay, given the problem, do I really need this data structure? Okay, do I need the data structure for the given problem? Okay, or I don't need data structure, I can just use algorithm. And if I need any data structure, what data structure that I need to choose? Okay, the most high level principle. So I need all that. Okay, I need all that in order to create a good algorithm with proper data structure. Okay, you can ignore this. Not necessary. Not necessary. Okay, so why we need data structure? This is the same problem. Okay, so the higher the speed that we have, the more complex that we will develop. Okay, you can skip all this. Okay, let's go to the summary. So make sure you understand what is a problem, what is algorithm, and what is program. Everything starts with a problem. Okay? If I don't have a problem, I don't have algorithm. So what is a problem? Is basically any task. That's the problem. Okay? Any task. So any task that has input and is matching output. So matching output is the solution. Okay? So you have a solution in here. So whatever input that I give, I need to have a proper output. Okay? But it has to include the constraint of resources. Meaning, I cannot simply put anything that I want to get my output. So you can view problem in terms of mathematical function. So you have input and then you have output. Okay? Now, if it is a function, meaning you only have a single output, okay, given a set of parameters for your input. Now, so that's the problem. So how do we solve a problem? Okay, we need to have the solution. Now, for the solution to be coded, okay, we need to build algorithm. Okay, and what is algorithm? It's a process to solve the problem. Okay, this is a simple definition. Okay, so you can view that as like a recipe. Okay, so a recipe to solve a problem. It must have series of steps, and it must be doable. Okay, it has to be doable because you are going to code this inside your computer. Okay. So for example, I have a problem, I want to sort something. So if I want to sort something, I have multiple algorithms. Okay, I can use insertion sort, bubble sort, selection sort, and many other type of sort. So one problem can have many algorithms because one problem can have many solutions. Okay, so it is up to us to give the best solution possible. Now, in certain circumstances, we may need to have this bubble sort. In certain circumstances, we may need to use merge sort. It depends. Okay. It doesn't mean that your sorting is the fastest one and that's the best one. What if your sorting require the highest processing power? Okay, so then it becomes cost-benefit analysis. Okay, so this is something that why we have multiple solutions for the same set of problem. Okay. Because in under different circumstances, we may need to use different solution. So these are the properties of algorithm. Okay? In order for you to say that that is an algorithm, it must have these properties. First, it must be correct, obviously. Okay? It must solve the problem. Okay? Because that's the objective of the algorithm. Next, it must compose series of concrete steps. The key word here is concrete. Concrete means there shouldn't be any uncertainty, which relate to the next one, which is no ambiguity, no uncertainty, no doubt. It has to be very, very clear. That is algorithm. For example, if I ask you how to go to KLCC using the bus, and then you tell me, you just walk 100 meter, and then at the corner there, there's a bus stop, and then you take the bus. Okay, that is not algorithm. Because that corner there is it left corner or right corner? Okay, so there's uncertainty. And then you take the bus. But what bus? Is it a school bus, factory bus, Okay, bus number 10, bus number 200. So it is not clear. Okay. So human, okay, when we give instruction, we always give this type of instruction because we assume that you know. We assume that you can figure out. Okay. But we cannot do that for computer. As much as we think the computer is intelligent, ChatGPT intelligent, they are actually very, very, very stupid. Okay? Computer is very dumb machine. If you give something that is not clear, it cannot perform. Okay? It has to be clear. So it has to be very specific, very clear. Then only I can transform this into computer code. Clear? So algorithm must be very, very clear. And it must compose of finite steps. Okay? It cannot be infinite. It must be finite. You must terminate. It must be able to stop. If it doesn't stop, basically it will hang. Okay? So it needs to have a concrete step. Okay, it must be a step. Okay, it has to be a step-by-step process. Very concrete, very clear, and at the end it has to stop. Then only I can take this and make this as a computer program. Okay. So what is a computer program? It's a concrete representation of algorithm. Because now you put that into a real coding, okay? In some programming languages, because you can code the algorithm in many different programming languages. Okay, so program is concrete representation of algorithm in some programming language. So this is a problem, algorithm, and this is a program. For example, this is, I want to find what is x to the power of 2. So this is algorithm. Okay, you can multiply x by x, x times x, or you can add x to itself. Okay, x plus x 2 times, same thing. Okay, sorry, x times 2. So x plus x plus x. So there are many ways. So in computer, we can use for loop. Okay, if you see Java, C++, you can use for loop. Or if you use assembly, this is the step. You can see even for simple command, okay, in assembly language, it takes a lot of steps. Luckily, you don't need to learn assembly language. Any questions so far? Any question? Okay, so remember, one of the first things that you will learn, okay, in this class is pointers. Okay, I've told you in our last lecture, pointers is where everything begins. Okay, pointers is the one that actually weave, the one that actually tie every single thing that you see inside your computer. So everything starts in your RAM, okay, in your memory, your computer memory. So to understand what's happening, how this pointer works, you need to be able to see what's happening inside the RAM, inside the memory. Now what I have here is a RAM. See, I bought from Shopee, 44. Now, this is example, this is a RAM. 4 GB. Okay? Very complex structure. Very small. Can you see? Can you see? Let me make this closer to you. Can you see? It's closer now. Can you see? If I can see, you can see. I jump, you jump. But inside this complex structure, inside this actually is very simple. So basically, conceptually, not physically, conceptually is a huge table. So this is the address, okay? And each address has a unique number. 1, 2, 3, 4, 5, 6 is 4 gigabyte of RAM. So it's roughly about 4.2 billion storage, okay? So on the right side is the content. So this is where we store everything. So when you run your computers, all your Windows, all your OS, everything is inside this, okay? But you can see this is not ordered in any way. So how do, for example, operating system know that this is related to OS, this is related to the Windows, this is related to your Explorer, okay? There are lots and lots of pointers. And this point to this, this point to this, point to this, point to this, point. You can say without pointers, this will never work, okay? There's pointers everywhere. But when you learn programming, you learn Java, you learn Python, you will not see these pointers. Okay? Now, in order for your computer to function, okay, at the very lowest level, you have the CPU, okay, the microprocessor. And in order for us to use the CPU, we need to use machine language, okay, machine language. Blah, 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 blah. Now, this machine language is 1 and 0 because your computer only understands 1 and 0. So when the processor is created, one of the first things that they need to code is the machine language. So your Intel, for example, is use x86 instruction set because this is the machine language for this particular processor. So every single CPU has its own machine language. If you use Apple, M1, M2, M3, they have their own set of machine language. So they are not compatible because they have different set of machine language. Different processor, different machine language. Your mobile phone cannot be used for your desktop because it's different machine language, okay? But machine language is very difficult for programmers to write something. So on top of this machine language, you have assembly language. So assembly language will convert this 1010 into something that we can easily understand. But it's related to machine language. So still, every single CPU has its own machine language. So Intel has a different machine language compared to Mac M1, M2, for example. But it's still not easy. Previously you see the code. This is an example of assembly language. Okay, even for simple stuff, there's a lot need to be done. But everything that you did, okay, all the program that you did, all the games, everything, eventually will be translated into this language. Okay, at the very lowest level, everything will be translated into this language because this is the only thing that the processor can understand. Okay, but this is still very difficult for us programmers to do. Now, inside this, there's still pointers. There's a pointers inside this, okay? So, because of that, we create another language which is above the assembly language. There are many languages, but one of the most popular one is the C language. And its object-oriented version, which is C++. So almost all the application that you're using now, almost all the languages that you're using now actually are created using C, C++. So we use this to create your Java, we use this to create your Python, and we use this to create a bunch of other languages, okay? Then you create your own app. So actually everything originates from C, C++, your operating system. Almost all operating system nowadays is actually comes from C and C++, okay? So this is at the lower level. And why this is at lower level? Because it can access pointers. It allows you to do this. It allows you to check what is inside the content of this. So if I check what is the address of it, then I can see the content. That is the power of the pointers, okay? To enable you to see the content of this. So you can access the address, the actual address. Now, if you use Java, for example, you can access the address. It won't allow you. So many other languages will not allow you to access the address, okay? Now, accessing the address is risky. There's a risk associated for this, okay? Security risk. For example, even if I write a password, even if I encrypt the password, so before I can encrypt the password, I will ask the user, okay, what is the password? So I need to store the password somewhere. Okay, so for example, so this one I get the user password, so input. Then only I encrypt the password. Then only the encrypted password is stored. But before I encrypt the password, I need to store what the user key in, the actual password the user key in. So this is stored somewhere inside this RAM. For example, here is the password the user put, and then later it will be encrypted. Then only I remove this, okay? But if I can access this, let's say this is address number 200. If I can access this, then I can see the content. I can see your password before it is encrypted. And you can do this if you have pointers, okay? So that's how powerful pointers is. That's why most of the hacking tools are done using C, C++, because you can access the pointers. Or you can do damage, virus, for example. Most likely is written in C, C++. If this is the address that linked to your entire hard disk, if I remove this, then you have no access to your hard disk anymore. Okay? So for this reason, most languages will not allow you to access the pointers. But if you can access the pointer, I cannot create the data structure. Okay? So most of the data structure that you see inside your Java, inside your Python is already created. Okay, it's already created using C, C++. Okay? And C, C++ need to have access to the pointers in order to create the structure. Okay? So in this class, okay, we will not learn this, we will not learn higher all this up here, but you learn from here, because this is where everything begins. Okay? So that's why you learn pointers in C or C++. Clear? Any questions so far? Any question? 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 Okay, don't forget Tuesday class next week. There's no Tuesday tutorial, okay? So your class will be next week. So your class will be 1 week late. So your class actually end in week 15, not week 14. And for tomorrow class, Wednesday tutorial, there's no class tomorrow, public holiday. So the replacement will be done next Tuesday, okay? It's not compulsory because some of you will have scheduling conflict. But if you want to come, you can come. Later, I will post the time and the date for each section. Okay, there's 6 sections altogether. The recording for this week will be done on that Tuesday. Okay, the tutorial for this week will be done on that Tuesday. Now, lecture will be recorded automatically. But normally I will load into your time as well. Because some of you have problem, okay, accessing other system. Now you will see the recording something like this, okay? It says recording week 1 lecture, okay? So for today class, for example, you will see recording week 2 lecture. And then another one, tutorial, week 2 tutorial, okay? But week 2 tutorial, you will see that next Tuesday. Okay, that's how you read the recordings, okay? Clear? Any question? Any question? And for those who have yet to send me your WhatsApp number, please do so as soon as possible. Okay? Okay, your attendance. Now remember, if you have to miss the class, you need to apply for leave. Okay, you apply for leave using Campus Central app. Clear? That's how it is automatically know whether you are absent or not. Otherwise, your absence will be counted. If you apply for the leave, then your absence will not be counted. Okay, toward your percentage, attendance percentage. Okay, and the other thing is, so next week, okay, we will start programming. Okay, so if you want, you can bring your notebook, laptop to the class, but it's not compulsory. Okay, only if you want to do the things together. Okay, otherwise you still need to do the programming, but you can do at home or during the weekend. Okay, entirely up to you. Clear? Okay, once you've keyed in the attendance, you can leave. Thank you very much. So I will see you next week. Okay, your assignment, okay, will be given in week 5 or week 6. Okay, because your assignment is totally group assignment, and the group can only be formed after the student number is finalized. The student number is finalized in week 5. Clear? So before that, you don't need to worry about the assignment. You cannot do assignment anyway, okay, until you learn everything, okay, until week 5.